So for a prop like this, I'd probably work high poly to low. Sometimes I'll work mid to high to low, but with the curves in the casing here, I feel like it's going to work better for me to just jump straight into the high poly. And I guess it's important to say that at this stage, there's a few areas that I'm unsure about. I'm not sure how to approach some areas just yet, and that's totally okay. Part of doing the high poly is figuring out the kind of topology that's going to work, especially for tricky areas. It can take a couple of attempts to get right. So I'm going to start with the main chassis, as it's obviously the most important, but it also has a lot of curves, which I'm going to want to figure out sooner rather than later, especially these kind of areas. Everything's very connected. So it can be a little bit intimidating to jump straight into the model, especially if you don't have a plan in mind. And for a prop like this, there's a lot of rounded areas that interconnect with each other. You can see that the chassis is, or the casing is quite seamless in places. So I always start by really looking at my reference. And sometimes I'll spend like a couple of minutes just looking at the photos and forming a mental plan of how that object is made up. And then normally an area will kind of stick out to me as a place to start. So in this case, I'm going to probably just start with the corners, because I feel like just getting in those big rounded shapes are going to help as like a jumping off point to the rest of the prop. Because at the moment it's very blocky and it's kind of hard to visualize how it's going to come together. So at this point, I'm also going to work with the existing block out. And I'm just going to add some edge loops and just connect some verts to really tidy it up. Because what we have is, as I said before, it's a good starting point, but we weren't really bothered about the topology. It was just about getting something in the viewport so we could visualize what we were going to do next. So it still doesn't have to be super tidy at this point. I'm just kind of trying to make the geometry a little bit more uniform so I can start building in control loops, and work out where I'm going to put bevels, if anywhere, smooth things out as needed. I'm going to time lapse through this bit because there's really nothing technical to it. It's just a case of going through the model that you've blocked out and cleaning it up, making sure you've got the geometry as clean as possible. And if you see areas where I look like I'm pausing quite a bit, it's because I have my reference on my other monitor. So I'm always looking at my reference. It's kind of like in life drawing. If you've ever been, the tutors will normally tell you off if you spend too much time looking at your paper rather than the model. And the same is kind of true here. I never really take my eyes off my pure ref board, because the minute that I do, I start modeling what I think I know rather than how something is actually constructed. And off the back of that, you can see, if you had sharp eyes in this time lapse, I actually adjusted the height of the two capsule units at the front. And that's because as I was looking at the reference, I kind of realized that I think I had them a little bit too stubby, and because of that, it meant that other parts of the model just didn't look to scale. So it's totally fine during this cleanup process to alter the block out. Sometimes even in the high poly, I end up altering things just because I've made mistakes when blocking out the shape of things, because you are trying to recreate what is like a 2D photo into a 3D space. So you don't always get everything right first time. So I fast forwarded just a little bit just to show you that the blockout hasn't really changed, but I have cleaned it up a whole load. So verts are actually connected. We don't have a million n-gons everywhere. And it just gives us a nice base to start putting in the corners that I mentioned previously. So now that the blockout is cleaned up, I'm picking the 5 main corners, which are the 4 outer ones, and then the one in the middle between the screen and the dial. And I'm just using the chamfer tool, the tool itself, not the modifier, just to add a big chunky bevel with an iteration in the middle. I am going to be using crease sets and open subdivide to smooth out the rest of the edges in the casing, But for these main corners, they're so characteristic, they're so important for the gas meter maintaining its characteristic shape that I want to control these with geometry, just because I feel it gives me better control over the silhouette and the shading. So you can see adding in the chamfers has messed up the geometry a little bit, so expect that there will be some cleanup in places like these. So just grab the target weld tool or move the vert along with the preserve edge option selected. And just make sure you're getting rid of those triangles and getting the edge flow back in. So at this point I've cleaned up the topology just a little bit. It's still pretty much the same model. It's just we can now start thinking about the high poly. So at this point, because we're going to use crease sets to drive the curves, I'm going to want to separate the top and the bottom of the casing off now, just so that we follow the design of the actual real life object a little bit closer. As long as we remember what values we're using in each of the crease sets, so that the softness of the curve stays consistent, but otherwise we're going to find it a lot easier to work on them as two separate objects. One thing that you might notice that I'm doing here is that I'm naming these two objects, and that's because we are going to use the Bake by Mesh name feature that both Substance and Marmoset have included. And I don't always remember to do it as I go, but whatever you can name now, it makes the whole bake setup process a lot easier. But it's also just a good habit to have your scene named and organized so that you don't end up with a list of object number in your scene explorer. Part of the reason that I wanted to separate the top half and the bottom half so early is because they have a lot of intersecting geometry that if we try to model all as one, we just end up with really bad results. So this bit in the middle, especially if you inspect the reference, the curved bit doesn't actually feature in the top section. It kind of sits on top, and that's great for us because it means that we can make this middle bit just flat, and it's going to be less complicated edge loops to fit in. So to bridge the gap, I'm just holding shift and then dragging my gizmo, and that just extrudes the edge out. And I just have snaps on so that it'll snap to it, and then I will weld at the end. So you can see straight away this is just going to be far nicer to try and model with rather than having a lot of shapes connected. I'm going to make sure that all the bottom are level. And then I'm just going to use the border tool, which I have assigned to the default hotkey 3, to select the border, and then I'm just going to press the cap button in the edit geometry window, and I'm going to be doing the same to the screen as well. So now that those holes are capped off, I'm going to use the inset tool to add a loop around this indentation on the top. You can see from the reference that there's a variety of edge bevels in this indentation. The angles around the bottom are quite sharp, but around the top where it meets the outer casing is a lot smoother. Adding these insets will help me control the way that the open subdiv modifier works with my model, and I personally like working with more control loops rather than less. I'm going to push the value on the inset tool up until the loop it's created becomes flush with this edge above the screen. And this is because I'm going to take this edge here and I'm going to carry it around underneath so that my topology stays fully clean. So I've just noticed that in this area here, I think I could improve the edge flow and tidy it up a lot, as I suspect this is going to smooth pretty jankily, and that will be a common occurrence during the high poly creation. Knowing what geometry is going to smooth nicely does come with practice. As you work on more models, you learn what is going to smooth well and what is going to cause artifacts. So I'm kind of accepting here that I think I'm going to have a triangle in my mesh. I normally try to keep everything in my high poly meshes as quads to avoid shading errors, but I've had to rotate around and I can't see anywhere that I can add another loop without impacting the smoothing in other parts of the model. And that's just because in an item like this, as I said at the start, there's a lot of interconnecting parts. It's obviously been made with a mold in real life, so there's not many seams that we can take advantage of. So I'm going to just leave this as a triangle for now, and then I might come back to it later after I've seen how it smooths. My next point of action is to rework the base shape of these two capsule-y segments at the front. When I first blocked out the model, I assumed that the sides of the meter were completely flat, but when I looked for some more reference to fill in some knowledge gaps I had, I noticed that they were actually rotated inwards. So I'm going to use a slightly unorthodox method of measuring, and that's purely because I've added a few edge loops to this model already. I don't really want to undo all that work, so I'm going to just draw out a small line with the spline tool, and then I'm going to snap it to the verts of one of the rotated edges so that their angles are the same. I'm then going to use that spline tool to help me measure the angles of the other capsule edges. And now there are scripts out there that can measure the distance and angles between verts, which might actually be useful in cases like this. Meow's Live Measure Pro being one of them. I hope I pronounced that right. But I don't have that script available to me for this demo, so I'm just going to use a spline tool to help me measure the angles and eyeball my way through it. Because these are going to be so smooth that after I apply the open subdiv modifier, I think any tiny fraction of difference is going to be unperceivable. At this point, I'm going to slap on a quick crease set modifier and an open subd modifier, so I can see at this very early stage what areas are getting smoothed already and by how much. And even though it's going to look terrible at this point, it gives me a good point of reference on where I should start putting in higher crease values and more control loops. For this test, I'm just using the select by face angle option in the crease sets, which will automatically select angles at a 90-degree difference, so I can then assign a crease value. This will include some edges I don't want hard-edged and miss out some that I do, but it will suffice for a quick test preview at this stage. So looking at the reference photos, I can see that I can get away with a cheeky little hack to make my life a little bit easier. This back section of the meter, we're never going to see it, so I can actually delete a lot of the back as long as I keep some inset. Deleting this means I don't have to worry about carrying edge loops the whole way around the model, which means I don't have to worry about it disrupting smoothing on the other side. As long as we have that little inset edge, we're never going to notice any difference from the back being deleted once the high poly is assembled. You can see if you study the reference images of this type of meter that although the corners and the edges are very smooth, the actual front faces of the casing is very flat. If we just slapped a subdivide modifier on the whole thing, the hard edges are going to try and smooth universally in all directions. And we don't want that. So I'm going to do something similar to insetting, except I'm going to do this manually with the cut tool so that I can work with the loops already in place. When working like this, it's always a good idea to switch between using edge constraints and face constraints as required so that you don't ruin existing geometry. And so if you're paying attention, you can see the subtle but important differences that those inserted control loops have made to the shading of the edges. And now that I'm happy with the look on this side, it's time to apply the same method to the right hand side face. I'm just going to time lapse through this section as it's fairly self-explanatory. I'm also going to add these two extra vertical control loops as I don't want the two corners on the extruding capsule bit to try and smooth across to each other. And you can also see that I've done the same inset method to the top of the capsule bit as I want to control the fall off of the shading on the top surface of that also. And I quickly preview with open subdiv again. I'm not too worried about how blurry the other edges in the model are at this moment, because I know I haven't applied any of my crease values yet. I'm going to time-lapse through some of this footage of me modelling out the top section, as a lot of the principles and approaches already discussed are applied here. I'm not really doing anything different, it's just a case of getting it done. And I'm mostly spending the time here to add some support loops underneath rounded corners for better control of smoothing, evening out edge loops, connecting loops where I think they'd be tidier or more optimized. So it'd probably be quite tedious to watch if you just watched it in real time. And occasionally I test out some crease sets with an open subd modifier. so that I can get an idea of how the final high poly is going to look. Unfortunately, the crease set modifier does have the downfall of losing the assigned information if you go back to the edit poly modifier, if you make changes in it. And for this reason, I usually just use the quick auto select by angle to preview the creases. I'll just put kind of a arbitrary value on, and that just allows me to preview the creases without spending time manually selecting edges carefully. And I'll do the final value assignments when I'm closer to the end of the model. For this lip on the indent here, I'm going to add a chamfer because I couldn't find a way of smoothing it how I wanted with just the basic geometry, and it wasn't accurately matching the reference. It's causing smoothing errors because the edges inside the indent, where the sides meet the floor, are super sharp, but all the edges around the indent are incredibly soft, which was creating a nasty transition. So I'm just adding this chamfer into the geometry and then doing the cleanup required to have the new edges blend in with the rest of the topology. And I'm also going to use this extra vert that's been created here just to add a control loop inside, and then one on the floor of that indentation as well. And just like with all the others, this gives me slightly better control over the smoothing. So now I'm going to show you the Open Sub D tool slowly, since I've jumped around a fair bit during this initial part. I keep it in the buttons here for speed, but you can also just search for it. Once applied, I'm going to bump the iterations up, and you can see that the control loops we've added have really started to help form the proper shape of the casing, and that's even without having any crease values set currently. I'm fairly happy with the smoothness as a rough base, but I'm going to want to work on some of the areas that have tighter edges. I'm going to have a quick look back at my reference to assess which ones, and then I'm going to add a crease set modifier underneath my Open Sub D. And if you're not familiar with this workflow, then you might be a little lost by this point in the tutorial. I'd recommend spending some time learning about creases as a concept. If so, getting started, I'm going to mark some of the edges that I want to be pretty tight, and I'm going to make a crease set with the color red. The color doesn't matter, but it'll help me to remember that they're the most extreme. I'll set the value to something above 0.1. I can also rename the set, which is useful if you're going to be working with a few and you're likely to get confused. Make sure you toggle the display crease sets button so you can see what you've already applied. I'm then going to make a second set designated to the color orange with a slightly lesser crease value, and I'll use this for areas that don't need to be quite so tight, like the inner corners around the screen that blend into softer areas. So I think that's about it for the top section for now. This has definitely been the trickiest part of the model, so hopefully it will be smooth sailing from here. Jumping onto the bottom bit, we can thankfully take advantage of the symmetry modifier for this one, as there's not as many unique shapes in this half. I'm going to quickly make sure that the bottom half is lined up with the top so that any smoothing is continuous between the two components, and that includes edge loops being in line too. And then I'm going to slant the outer corners here so that they line up with the top half. This middle lip here is giving me a bit of a tough time as I work out how it's constructed in real life. I'm just going to push some verts around so that it lines up a little better with the edges above, and it seems a little bit more set in that kind of cavity. Now, just like before, I'm going to inset these capsule bits so that I can control the smoothing, and then I'm going to start cleaning up the topology again. It's exactly the same approach here as we used in the first part of this video. I'm going to edit the loops so that this undulating lip in the middle has an inset as well, because if I start just adding control loops that are like vertical or horizontal here, it's going to cause errors in the shape. Again, I'm just previewing with a quick Open Sub D modifier as I go, paying close attention to how the smoothing matches up with the top bar that we've already done. Since we're starting to focus on the end result now, it's time to add a little bit of thickness to the top, as it's currently just an open hole. Either drag the edges out using the border selection, or cap it and use the inset tool. Add edge loops to the resulting lip and then clean up any topology that you need to. I still feel like this central cavity needs some work, so I'm going to just straighten out some of these wayward verts before I move on. Now I'm ready to start adding my crease sets just like before. There's not many hard edges in this half. I'm mostly going to focus on hardening the edges around this central depression and the top of the mesh as well. I've noticed that the four corners here are hard edged in the photo reference. I'm supposing that's a design choice, so I'm going to make sure to include those as I think they're going to create nice normal information. I'm going to flick open sub-D on and off and constantly refer back to the top half of the gas meter in order to make sure that everything is smoothed evenly. If you find any inconsistencies, then spend some time evening out and matching up the edge loops in between each half. So the next big piece we want to get sorted is the big canister kind of thing at the back. This one is fairly simple too and very smooth in a lot of places, but it does have some relief detail on the top which we're definitely going to want to include, as I think it adds a lot of character to something that would otherwise be pretty plain. I'm going to start by marking off and pulling these middle bits out, because I can see from the photo reference that the sides aren't completely straight the way round. Presumably these small extrusions allow extra space for the piping inside. I'm going to keep the angles and the geometry pretty shallow as I want these to be pretty smoothed and subtle. And I'm going to add control loops to the main body of the canister here to stop my smoothing trying to blend the top surface with the sides. I'm also adding loops to the two extrusions that I just made so that their shape gets somewhat preserved. I'm now adding a symmetry modifier just to make sure that the canister is identical on both sides, and then I'm proceeding to put in some very rough crease sets like we did in the casing, just so I can start previewing how things are smoothing up to this point. You can see there's a lot of nasty smoothing on the front here, where the thin extruded ledge connects with the main canister, so I'm going to need to add some supporting geometry around there to sort that out. I'm using the button that looks like a test tube at the bottom of the modifier stack, and this toggles the final result preview on and off, so I can constantly flick between checking how the open sub-D is responding to the additional edge loops. I'm also very quickly going to add some chunky bevels to the four main corners, just like I did at the very start of the video on the top half of the meter. And this is just because I want to create a better starting point for the shape of this thing and not rely entirely on a smoothing algorithm. Next, I want to just polish up these middle extruded ridges, these kind of wing things. It looks like they carry around to the front slightly and then taper off. So I'm just going to add a bit of roundness to the ends. I'm not worrying too much about the other side at this point because I am going to use the symmetry modifier at the end just to avoid having to do the work twice. I'm constantly rotating my model as I go and adjusting things. I still have my photo reference on my second monitor at this point, and I've noticed that the side extrusions that I added at the very start I think they need to be wider and more tapered. So yeah, never be afraid to constantly go back and tweak other parts of your model. It is the beauty of using a non-destructive workflow like this. On the top, I'm going to add an inset, as this is going to form the base for the relief detail, which I mentioned earlier, and I'm going to be modeling that in soon. I also want to get the indent in on this ledge here, so I'm using the connect tool to create a strip in the middle, and then using extrude with local normals to push it inwards. This indent will also need crease values applying to it so that it stays crisp and doesn't dry and smooth. Quickly taking a look at the prop as a whole, I'm kind of happy with how it's shaping up. It's starting to actually resemble the photographs now, and we've already come quite a long way since that really cubey block out that we started with. I'm now going to focus on that relief detail on the top of this canister, and to do that I'm going to be using the pro boolean functions. I'm going to start with a cylinder in the center and just make sure that the two pipe entries are visible. This is going to give me a sort of measuring tool for the more unique secondary shape. I'm then just going to use the spline line tool to draw out the second tier shape, and I'm just going to do this freehand for now. I only have to worry about one corner, as I'm going to use the symmetry modifier to repeat the other three. Once I'm happy, I'm going to use the shell modifier just to give it some thickness, and then I'll be using the pro boolean compound object to create a union between the base canister and the new shapes that I've just made. If you roll out the advanced options section in the boolean options, if you make sure that you have the no edge removal selected, this makes cleanup a little bit easier and it doesn't randomly remove other edges in your mesh. And after this, it just follows the standard cleanup that you expect after a boolean operation. Remove excess verts, connect your loops, make sure everything that can be is a quad. A lot of this part is finding clever ways to connect your verts and keep your topology tidy. And I'm also going to use this time to add insets to the top of these shapes, and just like previously, this is just going to improve my smoothing. So now it's time to begin assigning our crease sets again, just like we've done with the other parts of the high poly. I want to apply crease values to the detail that we've just put in, definitely. But I also want to add a fairly high value to the front of the canister, just where it meets the rest of the meter. Because I can see from the photo that it has a kind of sheared off look, which is in contrast to the soft edges everywhere else on this object. So now that the big chunks are done, we can start focusing on some of the smaller elements of this prop. This is always my favourite part, and I kind of feel like by getting the larger forms out the way first, I kind of earn the right to get started on the fun, smaller details. And some people might not feel the same way, that's just personally how I see prop creation. And first I'm going to take the block out of this dial plate, and I'm going to use the pro boolean function again to cut a hole into it. And this is where eventually the faceplate of the dial is going to sit inside. I always find for the boolean operations like this, to turn autogrid on when creating the primitive that's going to cut into the other shape. This just means that when you draw the shape out, it will auto snap to the surface that you're aiming for. As with the previous boolean operations that I walked you through, I'm going to make sure that I have edge removal turned off, and then I'm going to select the subtraction function. One neat little tip that I'd like to highlight for when you have a fair bit of cleanup is to install and use the Rapid Tools script. And this just contains a bunch of actions that are going to speed up your workflow. If you select the mesh cleanup, obviously after installing, you can see that this window has a few different options that we can use. If you select the Find Mid-Edge Vertices, this will select all of those floating verts that have appeared as a result of the boolean. And then you can either hit the remove button in the UI or press Ctrl and backspace to remove them. So first of all, I'm going to add these two extrusions at the top. Now these are two attachments that would, in real life, keep this piece anchored to the meter. And then if we didn't put these in, the piece would just look like it's floating on top, which would be incredibly unconvincing. So always take care to model in any fixtures. Then using a shell modifier, I'm going to add a little bit of thickness to the plate. It won't add a huge amount of difference, if any, to the bake, but I like to model things kind of how they're constructed in real life. It just helps me make sense of the object a little bit more, and I find through doing that as a practice, I tend to get closer to reality when I'm modeling. So time for the crease sets, and I'm just going to time lapse through these parts going forward, unless there's anything special that I'm doing, because otherwise this is going to end up as a very long and repetitive video, because my approach is exactly the same as I showed you at the start of the video. You can see I'm adding an inset to the front faces, and I'm also adding high crease values to the slanted corners to preserve their shapes after smoothing is applied. Next up, I'm going to make the dial face. Super simple, just going to make a cylinder primitive, slightly smaller than the cavity that it will sit in, and then connect the edges. And then I'm just going to use an open sub D modifier as with everything else, with the creases applied to the 90-degree angle. I'm going to come back to the dial a little bit later, as there's some smaller details that I want to tackle later down the line. You might have noticed by now that I do tend to jump around quite a lot, and that's just my personal way of working. I constantly shift priorities of the model around in my head, and sometimes I find jumping around helps keep my concentration focused too, but it's totally fine if you want to tackle the high poly model in more of a methodical one-by-one way. So from that, the next bit that I'm going to do is this raised ridge at the front of the gas meter. Because this would be a bit of a pain to model into the casing itself, I'm going to use floating geometry instead. I'm going to start with the spline tool and freehand draw the shape using my photo reference as a guide. I'm going to be using the symmetry modifier for this element, so I only have to worry about one side naturally. Once you've drawn out the basic line, you can use the fillet option on the spline tool to curve a hard corner nicely. Then make sure that the Enable and Viewport option is turned on and that the rendering type is set to rectangular. I'm also going to turn down the iterations just so the curve is a little easier to work with. So this ridge at the front is kind of sloped in the reference. It's not all 90-degree angles, so I'm going to add 2 loops to the front faces. And that means I can then delete the 2 original edges of the rectangle, the ones next to the loops I've just put in. Deleting them is just a faff-free way of sloping the mesh. After adding my control loops at the top of the ridge, I can apply the symmetry modifier. And then I can add the extra control loops on the sides of this ridge before proceeding to subdivide the mesh. And if I zoom out, you can see now that the ridge sits on top of that casing geometry just fine. Continuing on with the tiny details, next up is the lock area, or I guess it would be a key. This is where the gas inspector would detach the casing and retrieve all the 50p's that had been deposited in. And it's just a super simple approach here, just working with the block out that I'd done. I clean it up a little bit, make sure everything is quads. And then I make a new cylinder primitive that I'm going to use to cut a hole into this metal key. Position it carefully in the middle. I'm using a cylinder with a few amount of sides so I don't have a ton of cleanup to do. And then use the probe boolean compound object to subtract it. Again, we'll use rapid tools to clean up and then just fix any geometry that needs it. I'll then position the key where I want it using the block out to assist, adjusting the scale and rotation until it fits with the rest of the prop. I'm now going to add my control loops, apply my crease sets and subdivide the mesh to smooth it. I'm quickly going to show you how I tackled the padlock as well. This was super simple. I just started with the block out and extruded these sides a couple of times to get this stepped effect on the corners. And then I added control loops horizontally and vertically across the whole lock. I also used crease sets to harden these steps, as you can see here, as they were too thin for adding more control loops. Crease sets work well for areas like this. For the bar, I used a push modifier to thicken it up a bit and then just used a turbo smooth to smooth it out a touch more, as the original spline was already fairly high in iterations. So now that I've got some of the other lock elements in for context, I'm going to go back to the front casing and cut away the shape of the keyhole itself. I'm going to connect the verts on this curved lip here so that there's a singular vertex in the centre. I'm then going to chamfer that vert to create a quad, and then using this 10-sided cylinder for a guide, I snap the verts to match the silhouette of the circle face. Now you could use Pro Boolean for this as well, and I will be using Pro Boolean to build in more of the keyhole shape, but for getting this circle in initially, I find this method a little bit more controllable, but you can do it whichever way you wish. I then draw out a rectangle using the auto grid again, and this is one of the things we're going to be using Pro Boolean to subtract. So you can see I'm going to take care here to line up the bar as best as I can with the existing edges of the circle, and this is just so that I have minimal cleanup. I cut away the shape with a cookie cutter boolean option, and then I just start cleaning up the messy verts left over. Grab all the edges in the resulting hole and drag them backwards to add some thickness. After that, I'm going to use the cut tool just to add some surrounding loops around the hole, and then I'll be connecting, insetting and reworking edges in a way that is going to support my smoothing. Obviously we've edited our polys to get this keyhole in, so it's going to need a quick pass on the crease sets to repair any lost data, making sure to include the edges in the new keyhole that we've made. We can see inside the keyhole that there's an extra little circle detail, so I'm just going to spend a couple of minutes getting that in, as it's going to add nice realistic detail to the normal map. And then the last tiny little detail to add to this area is the tiny screws on this padlock bracket thing. And these are just super simple turbo smooth jobs. Next up, there's another one of these detail ridges on the front of the casing, and we'll be using the exact same approach as the one previously. I'm going to draw out the general direction of the curve with a spline. turn on the geometry and then start to modify some of the verts in the Edit Poly modifier. I'm also going to add a couple of extra loops in this inner curved corner so that it better follows the contours of the casing. I'm doing the same trick here to slant the sides. I'm adding 2 loops in the front faces and then deleting the original corners so that the whole thing tapers in. After I'm happy with the shape, I'm going to grab the border edges at the back and I'm going to fan them out so that once I apply shading, I'll get a nice gradient in the geometry that blends into the geo of the casing behind. Some small tweaks at the end, apply the symmetry modifier, and then I'm happy to call this bit done. With the symmetry modifier and the smoothing on, I'm just going to spend a few minutes tweaking the shape of this curve until I'm happy that it properly matches both the reference and the curved lip on the bottom of the casing. Again, I have that test tube button underneath the modifier stack turned on so that I can alter the base, edit poly, and preview the end result. At this point, I'm content with all the small details we've done, so I'm going to go back to the dial face that we left a little while ago. The first thing I want to get in is the pivot that the strange shaped hands will rotate around. Super simple here, I'll just clone the cylinder that we used for the dial face since I find it quicker than creating a new primitive. And then I'm just going to add the extrusions around the base, slope them out a bit, or just based on what I'm seeing in the photos. After this, we can tackle the weird semicircle hands that I'm guessing showed tenants their gas usage. Again, cloning the cylinder because I'm lazy, but not too lazy to name my elements. And I'm going to start off with the semicircle at the end of the hand, and then I'm just going to work backwards. I'll start by mirroring the semicircle to get the right angle, and then I'm going to extrude these 2 edges downward to construct the length of the hand. And this is just using the shift drag when I have those edges selected. I'm working completely upright for the time being. Once I'm happy with the shape of the hands, then I'll add the symmetry modifier and rotate it around the pivot. You can see that I'm doing some small tweaks by hand and some scale changes as I go until I'm happy that the shape matches the reference. Now I'm going to add a shell modifier to give this shape some thickness. I always find it most useful for odd shapes like this to work with flat polys first. Now here I've had a bit of a dub moment and I realised that the symmetry modifier won't achieve what I want. So I'm going to clone this hand that I've made, rotate it round the pivot 180 degrees, and then weld the 2 elements together. You can see I've added a control loop along the thickness of the dial hands here. I'm now going to add both my crease sets and my open sub D modifiers and begin working out what needs to be hard edged. The bends in the hands here need values added, else they're going to try and smooth to be round. I've also noticed some of the verts at the back are out of line from the shell modifier, so I'm going to fix those up, finish my crease set assignment, and then we're good to move on. The next detail that we need to add is the sense of depth to the dial. I can see in the reference that there's a slit cut out from the front dial face, and there's a second round plate that sits behind, and this is just going to again give us nice normal information. I'll start by taking the dial face that we already had, removing the edges in the center and insetting to create a hole for the physical pivot to sit in the center. I'm then splitting it in half along its thickness so that we have a front dial and a back dial, and adding a slight bit of separation between the 2. Make sure to cap off the holes on the inside that have been left from detaching. And then I'm going to use this thin rectangle to cut out a chunk of the one in front. Taking care to keep it in line with existing geometry and ensuring that the no edge removal option is checked. Then it's just the usual cleanup. After that, I'm going to delete all the faces apart from the front facing ones, because I can just use a shell modifier to add the thickness back in, and then you get the neatly connected edges both sides. Underneath the shell modifier in the same edit poly modifier, I'm going to remove some of the old edges from the front faces and instead inset them so that the dial face smooths better. I can see there's some more support loops needed around the cut we've made. The smoothing is a little bit janky, so I'm going to add in some extra loops to support the crease sets that we'll be applying next. Once the creases are set, and I'm not going to walk you through how to do them because since we have done that quite a lot already, but then just apply your open sub D modifier and rotate into place. We're nearing the end, but there's still a few big features that we need to get into the high poly. One of those is the display on the left. Luckily, this is one of the more simple parts to do with it being relatively flat. We're going to just start with a box primitive and draw it out to the size that we need. I'm going to use a mixture of the connect tool and swift loop, which I have assigned to N in my key bindings, to mark out where the flip numbers are going to go. Once I've blocked in the basic area, I'm going to make another plane primitive in the same dimensions that I want the individual numbers to be, and I'll use this to measure out the spaces. I can already see that I was a little bit off initially, so I'm just going to adjust those. I'm going to extrude these just as placeholders, but eventually I'll have the numbers as separate elements. This is just to improve visibility of where each of the elements go. Next, I'm going to use the imprint operation within the Pro Boolean tool to mark out where I want the indent of the dial to be. I'll draw a cylinder primitive and then spend some time matching up the verts to the edges in the main display face so that there's a limited cleanup. Once imprinted, I can scale down the inner face and create the slope that you see in the photographs. I'm going to use the front faces of the display back piece that I've already made to construct the plastic border for the flip numbers, since I've already marked in the loops, which makes this a quick way of getting what I need from the geometry. So selecting the front faces, I'll hold Control and drag them out to clone them. It's then a case of just deleting the excess faces so that I get a flat piece of geometry more resembling the border that I want. From there you can either extrude the faces out or use the shell modifier to give the piece some thickness. We'll come back to this bit in just a moment, but first I'm going to clean up the display back plate. We don't need a lot of the edge loops that we had used for measuring anymore, so they can be cleaned up. We want an empty hole behind the where the flip numbers are going to go so that they can sit recessed. To make the flip numbers themselves, I'm just going to take the planes that I'd made earlier and add some divisions to them horizontally. At this point you can either use the bend modifier or you can hand model the curve in since the shape is so basic, and I'm just going to do the latter. As with other pieces we've done up to now, clean up the topology and then add in your insets and control loops into the back piece so that we can get it smoothed. Make sure when you're doing your crease sets that you give the indented circle some low values so that the impression stays defined. After this, I'm going to go back to the plastic border around the flip numbers display, add control loops with a connect tool, and then apply an open sub D to that as well. The last small detail for this display area is the dial needle. Over time, I've actually ended up making so many of these that I've actually made a bunch of variations that I can just use in my projects now. Making this one from scratch, it's super simple. Start with an ellipsis primitive and drag out one or two faces to begin forming the point. Of course, make sure the pivot is in the center of the ellipsis so that you can rotate it round easily. I avoid having features like this at 90-degree angles as I feel it looks more natural that way. I'm going to blast through making this feature on the top left as it follows all the same principles that we've already covered. One thing to note though, don't cut the hole into the casing just yet. I'm going to make the cylindrical gorge on the inside as a placeholder, but the interior space that it sits in, I'll take you through that a little further down the line. One quick thing I'll highlight is that I am going to use floaters again for these little plastic screws. You could do them in Substance Painter too, but they're so quick to model that I just include things like this in my High Poly. Next up is this rubber cap thing on top. Again, this is pretty simple and self-explanatory compared to other things we've modelled up to now, so I'm just going to time-lapse through it. I essentially just used a bunch of insets and crease sets to add the ridges. It looks like there's detail or some sort of writing stamped in to some of the caps in the photos, but I'll handle that in the texturing stage. For the gas pipes, I'm fortunate to have photos of the gas meter both connected and disconnected, which helps us get a better idea of the shapes. I'll start with the base since they're extremely simple. After that, I'm going to tackle the nuts using a technique that YouTuber Aramis demonstrates on his channel, which I will link over the video. I'd recommend watching that tutorial as a supplement to this, as he takes you through a great method for making nuts and bolts, and it'll be a lot slower pace and more focused than this. After constructing it using this technique, I'm going to play with the proportions a bit, as I've noticed the nuts in the reference are a lot flatter on top. I flattened some of the loops out on top to remove the curve. And then for the second nut, I'm just going to clone the first one and adjust the height of the middle section. I still have my symmetry modifiers on, I haven't collapsed anything. And this is really useful because I don't have to build anything from scratch. Taking a moment to observe the photo ref again, I can see that we can probably get away with duplicating the base pipe in the low poly. The more complex pipe parts, which you can see on the left, can be done as additional meshes that sit on top. This will save us a fair bit of texture resolution going forward. I'm going to turn the iterations on the spline down so that the loops in this curved bit correspond a bit more to the length of the detail I'm going to put in. I'm then just going to grab the portion I want and start extruding. This collection of crevices is going to be real fun to texture once we get to that point, because of all the dirt and grime that's built up over the years. It's also worth noticing that I often switch my transform gizmo to local when doing this, and that's just so I can push rings about based on their local orientation and therefore preserve the shape of the pipe. I'm then going to quickly make sure everything is named appropriately to save headaches later and clone things over to the other side. Even though I will be duplicating the pipes in the low poly, having the high poly complete provides the complete AO once we go to bake, but it also is just, I find it best practice from a design point of view as well. Starting off for my own sanity, I'm going to reset the orientation of the pipe back to 0. I'm going to be using booleans again for the shape, so I just begin by blocking in the volumes of this contraption. Again, make sure you're always referring to the reference and not just modelling what you think you know. An example being here, I noticed that the chamfer on top is a lot thicker than the one on the bottom, and there's little details like this that will sell your model. Before I unionize these two cylinders, I'm going to think ahead and add ring loops into the horizontal cylinder that line up with the iterations of the vertical one. Once the two are combined, because the intersecting edges should be pretty much on top of each other, you can weld them easily, or even if there's slight deviations, I can just use the target weld tool to make sure everything's connected. And this way I'll have a much easier job than trying to manually connect edges around a cylinder. I'm going to fast forward to the cleanup again, but hopefully if you have sharp eyes, you can see that I'm utilizing the Rapid Tools Mesh Cleanup tool for this part as well. And this just helps catch any wayward verts. Once everything is tidy, I'll add my support loops and crease sets as usual. I played around a bit with my values here because I noticed there was a variation in the softness of edge in the reference that I had, so I would encourage you to spend some time experimenting too. The next tiny detail is this little ring or washer kind of thing, and I do apologize for all my terrible naming in this tutorial. I'm by no means a DIY or plumbing expert. Again, I'm going to be a little bit cheaty and just clone the horizontal section of that crossbar attachment we just made, and I'm then going to use the quick slice to quickly cut a segment that will make the basis of this ring. And that just means that it's automatically going to be the same size as the attachment that it sits around. Because this will most likely be entirely baked down, I'm not overly worried about the smoothing being perfect, so I'm just going to quickly slap on a shell modifier and then use very tight creases before whacking on an open sub-D modifier. We also can't forget this tiny little nozzle on the side. This is where the turn key will slot into. Just simple polygon modeling here, starting with a cylinder primitive. You can see that I got the shape slightly wrong at first, and again, just constantly flicking my eyes back to my PureF board helped me course correct. The aforementioned turn key is next on our list, and I appreciate we have done a lot of different and minute components now, so well done for keeping up if you have. Tackling the long list of small details can be a little bit tedious at times, but you can speed it up by eventually building up your own library of kit bashing meshes. Things like keys and needles and screws and nuts and bolts. So I just wanted to talk a little bit here about changing designs in a way that benefits your model. I always try to draw a reference from different places so that I'm not carbon copying a photo exactly. I started making this turnkey based off a reference that was very square and plain, and that was a reference that was like a gas meter with a key attached to it. But after taking it through to the high poly stage, I decided I much preferred the look of antique curved ones instead. And they were ones that I'd found from looking at reference of keys specifically. So that's what I'm changing it to here. Perhaps if you wanted a challenge, you could pick one or two features in this gas meter prop that you could swap out for something a bit different that you prefer or you think would make the whole thing a little bit more unique. I've stripped back what I was working on and I'm just starting to block out the shape with a flat plane. I'll be adding a symmetry and a shell modifier to this key, so I'm going to take this opportunity to clean up the edge flow now. Then apply the modifiers I just mentioned, set my creases and smooth it, before positioning the key against the nozzle that it fits into. And at this point you can see I make some extra final changes to the nozzle and rotate both of them as a pair so they're not at the dreaded 90-degree tangent. And I almost forgot, but there is another nut on the opposite side of the pipe attachment that we do want to get in before we finalize the high poly. Super quick, we can just clone one of the nuts that we made earlier, cap it off, extrude the cap we've just made, and then smooth it as we would usually. Once you're happy with all these attachments, it's time to rotate the pipe back to its splayed out position. You can group them if you want. I don't really use 3ds Max groups a huge amount. Here I'm just going to align the pivots of the pipe and then all the components and the attachments with the pipe connector that fixes the pipe to the gas meter, because this is where we're going to want to rotate it around. Once they're all aligned and the same, once all the pivots are aligned and the same, I can rotate them to the desired amount, all selected as one, and I'm just going to rotate them to about 45 degrees. So you might remember from earlier on, I said I was going to handle the interior of the analog gauge later down the line. Well, now is the time to do that. I'm going to make full use of 3ds Max's modifier stack to put in the last fiddly details without having to cut holes in my base mesh and massively rework it. So if you look at the reference for this little indent here, you can see that it actually interrupts the curve of the side of the casing, like it has been punched in after the curve of the casing was already molded. So to achieve this painlessly, I knocked the first open sub-D modifier down to just one iteration, which keeps the overall smoothing a little loose. I then apply an Edit Poly modifier on top, which gives me more geometry to work with, and it just means I'll be able to cut out the shapes that I need a little bit easier. So obviously I cut out the hole that the analog gauge will sit in first. I'll quickly say as well, for the interior of the gauge recess, because I will want to bake that too, I just quickly made a box, flipped the faces, and then deleted the front face. I used the chamfer modifier to quickly add some control loops and then just turbo smoothed. This is going to be so much in shadow that I'm only going to do it quickly. For this little screw recess here, I didn't want to use Pro Boolean as I don't want to have to collapse the modifier stack. Instead, kind of like what we've done previously, I used a separate cylinder as a guide, and then I just manually placed verts with the cut tool. Once I was happy, I just extruded the shape inwards and added an inset around. Since I was doing such a minor change, I opted to use the crease functionality within the Edit Poly modifier, rather than adding another crease set modifier. I selected the edges around the screw recess and I set the value to 0.12. Make sure that you set the weight of the edges to 0. Combined with the inset loop, this gives me the sharpness that I'm after. Finally, just add in the little plastic screw. Super simple. I just make a cylinder with some loops insetted, obviously edge control loops, and then just turbo smooth on top. And that, I think, is pretty much our high poly done. At this point, I'd probably take a couple of nice presentation shots of the high poly in Marmoset and update social media with it. And that's just personal preference because I like to show work in progress shots on personal projects. I wouldn't do anything fancy with it. It's more just a, hey look, I'm still working on things kind of thing.